Good morning, student. Today we are going to discuss about packing efficiency in simple cubic arrangement. How we can calculate the packing efficiency in simple cubic arrangement. So we know the formula packing efficiency P is equal to Z into 4 by 3 pi r cube divided by A cube into 100. Here this is the cube. This is the edge length. Here A is the edge length. So let edge length of the cube is equal to A. Now this is the radius of the sphere. Here let r is the radius of the sphere. Then volume of the unit cell is equal to length into breadth into height. So it's equal to the length, breadth, height all are A. So we put A into A into A is equal to A cube. So we relate edge length and the radius. We get A is equal to 2r. From this r equal to A by 2. This is the relation between edge length and the radius. Now we substitute the value of r in the packing efficiency formula. Packing efficiency is equal to Z into 4 by 3 pi r cube by A cube into 100. So before this we have to calculate the number of atoms in simple cubic unit. Number of atoms in simple cubic unit is 8. The atoms are present in the corners. 8 corners. So each corner is shared by 8 neighboring units. So number of atom in unit cell is equal to number of atom in simple cubic unit cell is equal to 8 into 1 by 8 is equal to 1. So number of atom in simple cubic unit cell is 1. So we substitute the value here Z instead of Z we substitute 1. So packing efficiency is equal to 1 into 4 by 3 pi. This is 4 by 3 pi. Here we substitute the value of r. R is equal to A by 2. So A by 2 whole cube divided by A cube into 100. We simplify this. Packing efficiency is equal to 1 into 4 pi A cube divided by 3 into A cube into 8. Okay, 2 cubes are 8. So we strike out the A cube and 1 4s are 4 and 2 4s are 8. So here now packing efficiency equal to pi into 100 divided by 6. Then we simplify this. We substitute the value of pi. Pi is equal to 22 by 7 or we substitute 3.14. 3.14. So we get packing efficiency is equal to 22 into 100 divided by 7 into 6. So 2200 divided by 42. We simplify this, we get 52.38%. This is the volume occupied by the spheres. Packing efficiency for simple cubic unit cell is 52.38%. Our vacant space is equal to 100 minus vacant space is equal to 100 minus 52.38 is equal to 47.62. This is the vacant space. This is the vacant space. Now let us write the summary for the packing efficiency in simple cubic unit cell. It's very important for 1 mark based. So number of atom in simple cubic unit cell is how much? 1. Number of atom is 1. Packing efficiency is equal to 52.38 or we can simply say 52.4%. Vacant space. This is a vacant space 47.62 or 47.6 we can simply say. Then coordination number is equal to 6. This is very important for 1 mark based. They will ask number of atoms in simple cubic unit cell, packing efficiency and the vacant space and the coordination number. So in simple cubic unit cell the coordination number is 6. Here 4 sphere on its own layer or 4 sphere in the same plane, 1 sphere on the top, 1 sphere on the bottom, all the sphere touching each other. So or we can write simply the diagram. Atoms are present in the corners, they touch each other, one atom in the top, one atom in the bottom. The coordination number is 6 for simple cubic unit cell. Okay, this is very important. How can we calculate the packing efficiency for simple cubic arrangement or simple cubic unit cell? The summary is very important. Number of atom for simple cubic unit cell is 1. Packing efficiency is 52.38 or 52.4. Vacant phase is 47.32 or 47.6. Coordination number is 6. It's very important. You keep in mind, student. Thank you.